Hi everyone, welcome back to Lulumath. This video is on examples and non-examples of functions. So to fully understand what a function is, we're going to look at some actual examples of functions and some relations that are not functions, and we're going to talk about why they're not functions to deepen our understanding of what makes a function a function. So you need to know what a function is to be able to fully understand this video, and there's a video on what makes a function if you want a refresher. Just visit lulumath.com or the Lulumath YouTube channel. So just a reminder that functions are relations in which each input has only one output. And functions can be represented in multiple ways. They can be represented algebraically, so like in an equation, numerically, like in a table of values or a set of coordinates, and graphically just means that they can be shown in a graph. It also can be shown as a mapping. So I want to know if the following relations are functions or not. So I have to look at each input that I see here, and I want to see, does each input have only one output? So my first input is -5, and it has an output of 2. Then I have an input of 3, which has an output of 7. Then I have an input of 14 with an output of -9. And then lastly, I have an input of 5 with an output of -1. So if I were to look at all of my inputs, I can see each input is different. So each input that I'm looking at here has its own output, has only one output. Now this -5 right here and this 5 right here are different inputs because one is a negative value, one is to the left of the y-axis. Since these are x values, if I were to graph them out, one is to the left of the y-axis, the other one is to the right of the y-axis. So they're two completely different inputs. So I can see that yes, this is a function because each input has only one output. And it's made clearer using a mapping. I will have one side for my inputs, and I'll have another side for my outputs. And I will list my inputs out here in numerical order, from least to greatest. So seeing that my inputs here are -5, 3, 14, and 5, I can see that my smallest input would be -5. My next smallest would be 3. Then I would have a +5 and then a 14. And now for my outputs are 2, 7, -9, and -1. Again, I will list them out in numerical order. So here I will have -9, -1, 2, and 7. So I can see here that this -5 is mapped to my 2. So I will put an arrow from -5 to 2. The 3 is mapped to the 7. The 14 is mapped to the -9. And the 5 is mapped to the -1. So as you can see in my mapping here, each one of my inputs is only mapped to one output. It has its own unique output. So I can see, yes, this is a function because each input has only one output. All right, looking at our next example that we have here, we have an input of -5, an input of +3, we have an input of 14, and an input of 5. So if you notice, my inputs here are exactly the same. And my outputs are pretty much the same as well. We've got a 2, a 7, a -9, but my 5 is now mapped to a 7 here. So if you see, even though I have an output that is matched to two different inputs, every single one of my inputs has its own unique output. So -5 is only mapped to 2. It's not mapped to any other numbers. 3 is only mapped to 7. It's not mapped to any other numbers. And although this 5 is also mapped to this 7, the 3 is not mapped to anything else and the 5 isn't mapped to anything else. So this is allowed. Outputs could be mapped to as many inputs as we want. The definition is that each input can only have one output. So the outputs don't have any restrictions. It's only our inputs that do. And then lastly, this 14 is only mapped to this -9. Again, seeing it in a mapping might make it a little bit easier as well. So again, I have my inputs and I have my outputs. And just like we had before, since my inputs are the same in numerical order, it would still be -5, 3, 5, and then 14. But now my outputs do not include this -1 here. So I will only put -9, 2, and even though my output of 7 is listed twice here, it's the same number, so I only write it once in my mapping. So let's put it in our mapping. -5 is mapped to 2, 3 is mapped to 7, 14 is mapped to -9, and 5 is also mapped to 7. So even though the 7 has 2 arrows coming to it, each one of my inputs is only going to a single output. Each one of my inputs has only one arrow coming off of it. So this is still a function because each input has only one output. All right, let's take a look at this next example. This time, our first input is -5. Our next input is 3. Our next input is 14. And then we have an input of -5 again. So if you can see here, this -5 is mapped to a 2, and it's also mapped to a -1. So this means that we have an input that has more than one output. -5 is mapped to 2 different outputs, so this isn't allowed. This is not a function. And seeing it in a mapping will make it clearer. So again, we have our inputs, and we have our outputs. And our inputs are the same as all my other inputs, except this time we don't have a +5. So we'll just put -5, 3, and 14. And then for my outputs, I have in numerical order -9, -1, 2, and 7. So if you see here, -5 is mapped to 2, 3 is mapped to 7, 14 is mapped to -9, and then -5 is also mapped to -1. So if you see here, this -5 has 2 different outputs that it's mapping to, so that's not allowed. So therefore, this is not a function because one input has more than one output. All right, in our last example, we have a mapping instead of a list of numbers or coordinates. So we can see that -6 is only mapped to 1, -4 is only mapped to -5, 0 is only mapped to 0, 2 is mapped to -5, but 2 only has one mapping that it corresponds to, and 3 is mapped to -4. So just like we had over here, just because an output is mapped from 2 different inputs doesn't matter. What matters is what the inputs are doing, and each input has only one output, so therefore this is a function. Okay, so now we're going to take a look at some algebraic representations of relations, and we're going to see, are these functions? So taking a look at our first equation, we have a linear relation. We have y equals 4x minus 3. We know that this has a y-intercept of -3 and a slope of 4/1. But I want to know, is this a function? Could this linear relation be a function? Well, just a reminder that our input is x and our output is y. And I want to know, when I put an input in, will I get more than one output? So for example, let's say I use an input of 5. How many outputs will I get? Well, right here, 4 times 5 is 20, and then 20 minus 3 is 17. So I would get one output. When I have an input of 5, I get an output of 17. But here's the problem. I have infinite inputs that I can put in here. So I'm not going to do this infinite times because that's impossible. So how am I going to know if this is a function or not? So I have to think logically. If I put a single number in for x here, if I have a single input, will that produce a single output right here? So if I do 4 times any number and then I subtract 3, will that give me anything other than just one number? It will only give me one number. So therefore, each input has only one output, and this is a function. Now, if you see when I graph it out, y equals 4x minus 3 right here, I can see that no matter what my input is here, I'm only going to have one output as I travel along this line. It does not matter where I am, I only get one output. Now there's a special test that we can use called the vertical line test that will tell us whether this is a function or not. Make sure you check that video out because that will provide some clarity on this and allow us to find an answer very quickly. Let's take a look at our next example. Y equals -2x squared minus 5x plus 1. This is a quadratic relation. So I can see that my inputs are x and my output again will be y. And I want to know, will a single input produce a single output? Let's try an example. So let's try x equals 2. So every time I see an x, I will replace it with 2. So y equals -2 times 2 squared minus 5 times 2 plus 1. So I will do y equals negative 2 times 4 because 2 squared is 4, and then I'll just copy the rest of this down. And now I will multiply, so negative 2 times 4 is negative 8. Negative 5 times 2 is negative 10. And then I've got a plus 1. So negative 8 minus 10 is negative 18, plus 1 is negative 17. So seeing here, I see that a single input will give me a single output. But again, there are infinite inputs, so I can't do this infinite times. So I want to know, will this always happen? And it will, because negative 2 times some number squared minus 5 times whatever number it is that you're using plus 1 will only result in a single answer. Therefore, this is a function. And if you see, no matter what my input is, I only get one output, no matter where I am on my graph. All right, let's take a look at this next example. So x squared plus y squared equals 16. So here our input is x and our output is y. Will using an input produce a single output? Let's find out. So to make our lives easier, let's just use the input of 0. So x equals 0. So every time I see an x, I'm going to replace it with a 0. So 0 squared plus y squared equals 16. Well, 0 squared is just 0. So 0 plus y squared is just y squared. And then in order to solve for y, I need to square root both sides. Now here's where we need to be careful, because the square root of 16, yes, is 4 because 4 times 4 is 16, but it could also be negative 4 because negative 4 times negative 4 is also 16. So here, our single input produces two outputs. So just because we have just one input, all that it takes is just one input that produces more than one output, it's no longer a function. Therefore, this is not a function. Now, on that note, let's say our input instead was 4. So 4 squared is 16 plus y squared is still 16. And then I subtract the 16 from both sides. I get y squared equals 0. So the square root of 0 is 0. So in this situation, when our input was 4, we still got one output. But that doesn't matter, because even though we have a point where the input only produces one output, we have at least just one point that produces more than one output, which automatically makes it not a function. Every single input can only have one output. So if you remember, the graph of x squared plus y squared equals 16 should give us a circle with a radius of 4. And we can see here when our input was 0, we had two outputs. We have this 4 that we see up here, and we have this negative 4 that we see down here. Even though the input is 0, we have more than one output. And the same thing is true with any input. So for example, 2, but we have the point 2, 3.464, and then we have the point 2, negative 3.464. So our input of 2 has two different outputs, which means that this is not a function. Okay, in our last example of y equals 3 to the power of x, we have our input of x and our output of y. And if I take any x value, so let's say, for example, x equals 4, I would end up getting y equals 3 to the power of 4. And 3 to the power of 4 is 81. So my input of 4 gives me a single output of 81. And if I raise 3 to any power, I'm only going to get one answer. Therefore, this is a function. Because each input has only one output. And if you see here, no matter what my input is, I only get a single output. So therefore, it's a function. Please stay tuned for the video on the vertical line test, because that will give us a quick, easy way to determine if a graph is a function or not. That's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.